Good morning, everyone. Hopefully everyone's doing well. I would like some green checks so we can make sure everything's going well here. And then if you have any questions from the learning guide, I know Taylor had one from last day, which I'll get to. I have it here queued up. And then anything else from the last lesson, the solving by elimination that maybe you had, I'd be happy to go through that first. And then we're going to do the last lesson in Unit 7. And then we'll see where we're at. I might be able to go back and do a few more of the word problems because those can get tricky that we looked at last day. There's actually one in the notes from today. So that's it. All right, we got a load of green checks. And Taylor, I don't remember which letter you wanted. Was it 10B or 10A or 10C? From page 3. And then I'll go through that and then jump into today's lesson. Somebody remember which question it was? 10B. All right. That's what I thought it was. So it says determine the number of solutions for the following linear system. So with a question like this, we're not actually solving the system. We don't need to find out what the solution is. It just says how many solutions are there. Remember, there's 3 scenarios. We can have one solution, and we can have 0 solutions, and we can have infinite solutions. So those are the 3 scenarios we can run into. All right. If I look at the equations real quick, the easiest way to do this is to convert these into slope-intercept form and then compare the 2 lines. So I'm going to do that. Maybe I'll label my lines first. We'll call the top one number 1, and we'll call this one number 2. So if I start with number 1, x minus 8y is 24. I'm trying to get y by itself, so I'm going to move it to the other side. 8y plus 24. I'm going to subtract 24, so x minus 24 is 8y, and then divide everything by 8. So I get 1 over 8 times x. 24 divided by 8 is 3, is y. So that's my first equation in simplest form. Then I can do the same thing with my second equation just to compare them. So 2x minus 16y is equal to 30. I'll move the 16 to the other side, subtract 30, get ahead of myself, 2x minus 30 is equal to 16y, divide everything by 16, so I get 2 over 16x, 30 over 16 is y. 2 over 16 is the same thing as 1 over 8. X. 30 over 16, I don't know what that is, but I guess I could take out a 2, so I could get 15 over 8 is y. So when I look at these now, one thing I notice is that my slopes are the same, but my y-intercepts are different. One is -3 and one's 15 over 8. So if you think about what this would look like on a graph, I have an y-intercept of -3. So my blue line would be down here somewhere, and then my slope is 1 over 8. So I have a line that looks something like that. And then 15 divided by 8 is going to be really close to -2. So my green line would be up here, and it also has the same slope of 1 over 8. It's maybe not the best diagram in the world, but you can see that my lines are parallel. I have different y-intercepts, parallel lines, because the slope's the same, so I know I have no solutions. Because parallel lines. Now, I need to be careful with parallel lines, because if my lines are parallel and they have the same y-intercept, that means they're going to be on top of one another, and I'll have coincident lines or infinite solutions, but that's not the case here. I have different y-intercepts, so that's what we're doing there. I see there's another question in here, And Abby, yes, I do have a bit of a cold, I guess. I don't know, it's just kind of I have some congestion. I wouldn't call it a cold. I'm not sneezing and things like that, so. But I don't feel great. All right, page 5D. I'm not sure what that is, 4, 5. Oh, it's the only one there. And what are we doing here? Solve the system by elimination. Okay. All right. I guess there's a couple ways we could do this one. First thing I want to do is maybe try to get rid of the fractions, because I don't like dealing with fractions. Once I've gotten rid of my fractions, I can then go from there. It might be a case where we don't have to, well, let's get rid of the fractions first, and then we'll go from there. It might just work out that we have an x or a y term that's the same, so we can eliminate, but it might not. So I'm just looking at the first one. I see I have a 2 and a 3. My sort of lowest common multiple, or least common multiple of those two things is going to be a 6. So I'm going to multiply everything by 6. And here I have a 4 and a 3. So if I multiplied everything by 12, that would get rid of all my fractions. So let's see what my equations look like. 6 times x divided by 2 is 3x. 6 divided by 3 is 2, so I get minus 4y is 36. And then my second equation, 12 divided by 4 is 3, so I get 3x. And then 12 divided by 3 is 4. And 12 times that is negative 12. Did I do that right? I'm thinking that is good. Just trying to double check my math to make sure I kind of did 2 steps at once. So 6 divided by 2 is 3. 6 times 2 is 12. Divided by 3 is 4. That looks good. 12 divided by 4. So it works out that my y terms are the same and opposite. So you could do 2 things on this question. You could add these together, which would probably be my first choice, and that would get rid of your y's, which is kind of nice. Or you could subtract them, and if you subtracted, you'd get 3x minus 3x, and that would get rid of your x's. And we get negative 4y minus 4y, so we'd end up with negative 8y. So I'm going to add these things together, and that's going to get rid of my y's. Those are going to give me 0 y's. So 3x plus 3x is 6x. 36 minus 12 is that 24, I'm thinking? Yep. All right, so I have 6x is 24. X is going to be 24 divided by 6, which is going to be 4. And then I'm going to substitute that back in. It's asking for a solution, right? Yes, find a solution. All right, so I'm going to put x is 4, I guess just into my first equation here. I'd have 1/2 times x minus 2 over 3 y is 6, and then I'm going to put x is 4 into this equation. So I'm going to get 1/2 times 4 minus 2 over 3y is 6. Half times 4 is 2, minus 2 over 3y is 6. I'm going to subtract 2 from both sides. So we get negative 2 over 3y is 4. I'm going to multiply both sides by 3. Maybe I'll show this step. That's going to get rid of my fraction there. So I have negative 2y is 12. And then divide everything by negative 2. So I get y is negative 6. So my point is 4, negative 6. 4 is from here. Negative 6 comes from there. So that's my solution. And I could go ahead and check by plugging that point back into both my equations, which is going to be a bit of a pain because I have so many fractions to deal with, but it kind of worked out nicely. It's not absolutely terrible. So you're allowed to get rid of either the x or the y. Yeah, it doesn't matter. If you got rid of the x, then you get y equals and then plug the y back into one of the original equations. If you found the x, you'd get x equals and plug that back into the original equation. It doesn't really matter which way you do it. And like so many things we do in math, there's so many ways to do these problems. And you can literally like do them 100 different ways, and no way is more correct than the other. Isn't 4 times 3 13? I don't think so. I think 4 times 3 is 12. Did I not write 12? I'm just trying to find where I went 4 times 3 and got... I did 4 and 3 here, and I got 12 on the right side. Okay, perfect. I did go a bit fast. I guess my hope is that you guys had already done this. So by just going through it, you're just checking your answer. Maybe some of you haven't done it, and you're copying it down. You might have to go back, look at the lesson after, get it down. I see there's one more question. Where was it? Page 4, 4B. All right, this is a good question. This is kind of what we did yesterday. So solving by elimination. So we have 2 equations, and we're going to either add or subtract them to get rid of one of the variables. Once we've eliminated a variable, we are going to solve for the only variable that's left, and then substitute that back into one of the original equations. So the good thing about this question is it's already lined up for us. Everything's kind of lined up nicely. If I added these equations together, I'd get negative y plus negative y. So that would give me negative 2y, and then 2x plus 3x would give me 5x. So nothing goes away if I add. So what I need to do is subtract these equations. And by subtracting, I'm going to get negative y minus negative y, which is going to make my y's go away. So if I'm subtracting, what do I end up with? So I go 2 minus 3 is going to give me negative x. My y's are going to go to 0, so I'm not even going to write it. And then I'm going to get 14 minus 17 gives me negative 3. So I have negative x equals negative 3. There's kind of 2 ways you can look at this. I think the easiest way for me is I have negative x, so I'm just going to multiply everything by negative 1. Or you can think about switching sides, or you can think about dividing by 1. Any way you slice it, you're going to end up with x is equal to 3. Then I'm going to pick my equation, so I'll just start with the first one. 2x minus y is 14. I'm going to put the x in, so 2 times 3 minus y is 14. 12 is 14. Subtract 12 both sides. End up with 14 minus 12 is going to give me 2. And I get y is negative 2. So my solution is 3, negative 2. Yeah, so there's kind of lots of little finicky sign things in that question where you could be going and you just got to watch. You have negatives on both sides, just kind of strange stuff going on there. So yeah, hopefully just basic math errors. When we're doing algebra that kind of gets really complex like this section does, there's lots of places to make mistakes with our signs. What are you going to do? Take your time, I guess, is the solution. And don't be afraid to use your calculator to test out the math that you're doing. Because if you end up with the wrong sign, even though you might have done everything right, you're going to get the wrong answer. And the kicker is, on a multiple choice exam, they've purposely gone through the questions with common mistakes and they find the answer. So when you get to the answer, you're like, oh yay, my answer's there. And then you circle it and then you find out it was wrong, which is really bad because you thought you did it right. Okay, let's have a bit of a look here at lesson 3. Now, this is really similar to what we did last day, and I have a feeling you guys are going to be really good at it. I think the only thing that maybe gets a little bit, not necessarily difficult, is just this method is probably easier to think about, but it ends up being more algebra, generally speaking, like more calculations to get the answer. But we're just doing the exact same thing again. Last week we did graphing to find out where those lines intersected. Yesterday we did elimination, where we added or subtracted two equations together to figure out what x and y were, or where those equations intersected. Today we're going to solve by substitution. So the exact same thing. We're trying to figure out where our lines are crossing. Where they cross is the solution to the system. And we're just going to look at doing it a different way. So here we go. Solving a system of equations by graphing can take a lot of time. So graphing, first you're going to have to convert to slope-intercept form. Once you've done that, you're going to have to draw a graph, plot them. Hopefully your graph is good and everything lines up properly. Then you might get a solution. Once you do that, you have to check. That can be a lot of work. So another strategy we can use is called solving by substitution. All right. So you can see that the questions look absolutely identical to everything we've been doing so far. But in this case, it says solve by substitution. So we need to solve by substitution. So here's our two equations. We have 2x minus 4y is 7, 4x plus y is 5. It is appropriate to number the equations 1 and 2. So just the process that we always do to make sure we don't confuse our lines or anything like that. Once we start multiplying them, things get a bit confusing perhaps. I'm just going to go through the example and I think you'll be able to kind of follow. It's not terribly confusing or anything like that. So we've labeled our equations. That's the first thing we do anytime we solve a system. We're going to solve equation 2 for y. So what I mean by that is we're going to isolate y, get it by itself. We're going to get y equals something in equation 2. Now, why didn't I choose to do this for equation 1? And when I did select equation 2, why did I pick the variable y? Why didn't I pick x? Can anyone see what's maybe kind of obvious there? In terms of the two equations and the fact that I chose the second one and I chose the variable y. If you think a couple steps ahead, or maybe in terms of some algebra or something like that. And that's exactly it, yeah. It's just one y. There's just one y. So if I was solving for another variable like an x or something like that, I would have to divide everything by, whatever number was in front of it to kind of simple it out. And then I'd end up with a bunch of fractions, and I don't want to deal with fractions, right? We try to avoid fractions because they can be a little bit more work. So you guys are all on the right track already. You've recognized that it was by itself, no coefficient in front. So we could just write something like easiest to isolate that variable. So there's nothing in front of it. That's why we picked it. All right, so I'm just gonna maybe do a bit of a little calculation over here on the side. I'm sure you guys can see where this is coming from, but I'll just show my steps. So I have 4x plus y is equal to 5. I'm going to subtract 4x from both sides. And I'm going to get y is negative 4x plus 5. I just switched the order of those things. All right, so the title of the lesson was substitute, or solving by substitution. So what I'm going to do is I'm going to take this y is equal to negative 4x plus 5, and I'm going to substitute it into the second equation. Or sorry, I meant the first equation. I don't want to substitute it back into itself. That doesn't really kind of make sense. I'm trying to solve the system of equations, so I know I can isolate y in the second equation. Once I figure out what y equals, it's just, remember the variables and all this? These are just numbers, but the variables just hold the place of a number, so we don't know what the numbers are. So if it says y is equal to negative 4x plus 5, it means y is the same thing as negative 4x plus 5. They're identical. So anywhere in an equation I see a y, I could have a y there, or I could have a negative 4x plus 5. It doesn't really matter. So what I'm going to do is I'm going to take equation number 1, which was 2x minus 4y equals 7, and I'm going to put this negative 4x plus 5 in for the y. So it's going to look like this. 2x minus 4. And then I'm substituting negative 4x plus 5. So everywhere in that equation where there's a y, I know y is equal to negative 4x plus 5. So at this point, if I just look, you don't even need to write this little star in here, but if we're just looking at this equation, you'll notice that the only variable I have left is x. So I can get x by itself by, doing some multiplication, combining like terms, all these things we've done before in the past. We're just kind of putting them all into one question now. And because the only variable in that equation is x, I can figure out what x is. If I can figure out what x is, I can plug it back into one of my original equations and then figure out what y is. That's the idea. Let's see how that works. So I want to get x by itself. I'm going to have to do some algebra, bed math sort of things. So I'm going to leave this 2x, and what I'm going to do is multiply this negative 4 through the bracket. So negative 4 times negative 4 is going to give me 16x. And then negative 4 times 5 is going to give me negative 20 is equal to 7. So before I can combine like terms, I have to expand. If you think about bed mass, I have to do my multiplication before I can do my addition and subtraction. Now that I've multiplied that 4 through the brackets, now I can combine my like terms. So I have 2x and 16x, which is going to give me 18x's. So just combining these two things together, minus 20 is 7. And then I'm going to add 20 to both sides. And that's going to give me 18x is 27. And then I'm going to divide both sides by 18. Gives me x is equal to 27 over 18, which I can then simplify. I'm thinking, I could probably pull a 9 out of both those things. So I end up with 3 over 2. All right. So all of the algebra you guys spent time doing in grade 9, all of the algebra we're working on in grade 10, it all kind of comes into this one sort of question. We have expanding, we have combining like terms, we have isolating a variable. It can be a lot to take in, but it's all stuff you've done before, just kind of doing it in one question now. So we know x is equal to 3 over 2. So what we're going to now do is just like the elimination questions we did last day, x is 3 over 2, and we're going to substitute that into equation number 2. It doesn't really matter which one you pick. You can do either one, but we'll do it that way. All right, so we had equation 2 was 4x plus y was 5. I'm going to go 4, and then I'm going to substitute everywhere there's an x. I know that is equal to 3 over 2. So a little bit more algebra here. All right, so I got 4 times 3 is 12, divided by 2 is 6. So this all simplifies to give me 6, plus y is 5. And then I'm going to subtract 6 from both sides. I'm going to end up with y is negative 1. So there we go. I have a solution. My solution is, it's always going to be an ordered pair. Try to squeeze it in here. My x was 3 over 2. That was from up here. And then my y is now negative 1. So I have a solution to this system. Now that we have a solution, we can always check to make sure our solution was the correct solution, because we can end up with, an answer, especially with all the algebra. If we made any mistakes along the way, we could end up with something that wasn't necessarily right. So we always want to check. I'll verify this one because it's the first one we're doing. Okay, let's start with equation number 1, which was 2x minus 4y is 7. My x is going to be 3 over 2, and my y is negative 1. So I have 2 times negative 3 over 2 minus 4 times negative 1. So that was my y, is 7. Why did I get a negative 3 over 2 there? That was silly. So, not sure where I got my negative from, but it's just positive 3 over 2. All right, so 2 times 3 is 6 divided by 2. It's going to give me 3. So this all gives me 3. Negative 4 times negative 1 is positive 4. 7. So I get 7 is 7. Did the page not print for anyone else, or was that Abby's printer just being mean and eating it for breakfast, possibly? Might just be you, Abby. Sorry. The second equation was 4x plus y is 5. Same process. I'm going to plug in x was 3 over 2. And I have y was negative 1. And then I get is 5. So 4 times 3 is 12 divided by 2. Should give me 6. And then I'm going to get minus 1 is 5. And I get 5 is 5. And these questions are especially like that, Abby, when everything just kind of works out so nicely. It's just like, it just feels like you're doing everything correctly. And every once in a while, you'll end up with some bizarre fraction as an answer. And, you'll go through a whole question, you'll be like, this is just seems wrong, this fraction, but, it might be right. So you just need to have confidence in what you're doing. You can't go through this stuff being like, oh, I think this is wrong, I think this is wrong, I'm going to have to do this again. Just, take your time, do the best you can, and if it works out that you didn't end up with the right answer, then you're going to have to go back and figure out your mistake. But it's good to have confidence while you're going through these things, because they can be a lot of work. Okay, so we ended up with 7 is 7, so it satisfied the first equation. We ended up with 5 is 5, which satisfied the second equation. So it satisfied both equations, so we know that's the right answer then, which is cool, because where else can you just check to make sure you got the right answer? That doesn't happen a lot in school. Solving a linear system with fractional exponents. So this is the same question we're going to solve by substitution, except we have the fractions of both the questions. So it's kind of like the one I did at the beginning of the block. Now, when we don't have to deal with fractions, generally speaking, that makes life a little bit easier. So we'll follow the steps from the previous question. We'll just go through it. We're going to label our equations first. So there's equation 1. There's equation 2. I don't like dealing with fractions. Generally speaking, students don't. So if we can write the system with integer coefficients, then we don't need to worry about fractions, which is kind of good. So if we look at the first equation, how do we get rid of those fractions? What's the least common multiple of our denominators? So in this case, we're looking at a 2 and a 3. What can we multiply that by to get rid of all of those fractions? And then same thing for the second equation. We're looking for the least common multiple of 4 and 3. What's the least common multiple of those guys? So let's start with the first one here. What can I multiply everything by to get rid of the denominators there? And Ava is on it. Abby has found her page and given the correct lowest common multiple. So if I multiply everything by 6, that's going to get rid of all of my fractions. So think about this like I said before, we feed the chickens. Everything inside the brackets gets the negative 6. So 6 times 1 is 6 divided by 2 is going to give me 3x. 6 times 2 is 12 divided by 3 is 4y. And 6 times negative 1 is negative 6. All right, that was the first one. The second one, least common multiple of 4 and 3. What can I multiply 4 and 3 by to get rid of my fraction? In this case, it's going to be 12. I need to feed my chickens. Everything inside the brackets gets that 12. So I have 12y. 12 divided by 4 is 3, and 12 times 5 is 60, divided by 3 is 20. There we go. Okay, so all we've done is we've just gotten rid of our fractions. Now we don't have to deal with fractions. Actually, turns out we will have to deal with them eventually. But right now, we don't have any fractions to deal with, so we're doing okay. The whole point of this is solving by substitution. So I need to say, is there any variable that's going to be easy to kind of isolate? And I noticed one thing. This is where it can get a bit weird, because if we wanted to just solve the system, we could solve by elimination, because both of my equations have this 3x. So I could just subtract my equations and it would work out. But that's not the point of this lesson. It's solving by substitution. So can we use that 3x to our advantage because it's in both equations? And it turns out we can. So if we take equation number 1 and instead of solving it for just x, we solve for 3 times x. So just write a little note in here. Both equations share 3x. So we're going to use that to our advantage. So I'm going to take this 3x plus 4y is negative 6. I'm going to subtract 4y from both sides, and I'm going to end up with 3x is equal to negative 4y minus 6. So this is maybe where this gets a little bit weird. So we're going to substitute 3x into equation number 2. All right, so that's kind of confusing, but we're going to go for it. So what did equation number 2 look like? It looked like this. So this is equation number 2. 12y is 3x minus 20. And what I'm saying is 3x is equal to this negative 4y minus 6. So everywhere there's a 3x in this equation down here, I can plug in negative 4y minus 6, which maybe doesn't seem super obvious at first, but we're going to go for it. So instead of writing 3x, I'm going to write this as negative 4y minus 6. And then I'm going to take away 20. So I've just substituted negative 4y minus 6 in where there was a 3x. Change that color to make it a little bit more obvious. All right. Now, remember the whole idea here is that we're trying to figure out what x and y are. And by substituting 3x was equal to negative 4y minus 6, what we can do is basically get rid of the x variable. So if we look at our equation here now, where we've left off, there's no x's in the equation. So we can isolate y, just get y by itself. And that's what we want to do. So let's continue this up here, and we'll solve for y. So we have 12y is equal to negative 4y minus 26, just combining these two together. And then I'm going to add 4y to both sides. So 12 plus 4 is 16y is negative 26. And then divide both sides by 16. It's going to give me y is negative 26 over 16. Can I simplify that any further? It looks like I can pull a 2 out of both the top and bottom. And I end up with negative 13 over 8. That's an excellent question, Abby. We could theoretically do it the other way where you just substituted x instead of 3x. And yes, you could. And there's nothing wrong with that. The only problem you're going to run into is that when you isolate for x, you're going to have to divide everything by 3, and you're going to end up with fractions. And it can get really messy to do this sort of algebra with fractions. So instead of doing it that way, if you can find perhaps a simpler way, like finding what 3x was equal to because it was shared in both equations, it just makes your life easier. But if you were to just solve for x and complete the equation like that, there's nothing wrong with that. It just may be more difficult. So we're just trying to figure out the easiest way to do this instead of perhaps dealing with some complex sort of fractions and things like that. All right, so just like we've been doing, we've isolated for a variable. We know what y equals now, and we're going to substitute that back into one of our equations. It doesn't matter which one. What we'll do is maybe go y is negative 13 over 8, and we'll substitute it into maybe the first equation. So my first equation was 3x plus 4y is negative 6. And have 3x plus 4, and instead of y, I'm going to substitute in negative 13 over 8. So from this point, it's exactly the same as the other methods we'd been doing. All right, let's see how we can simplify this. It's going to get a bit messy. 3x, 4 times 13 divided by 8. I'm going to get 13 over 2, because the 4 and the 8 are going to simplify to just give me a 2 on the bottom. So that's looking okay. Now I'm trying to get x by itself. We're trying to isolate x, get it by itself. So I'm going to now add 13 over 2 to both sides, because that is the opposite of the subtraction that I'm doing. Continue up here. 3x is equal to negative 6 plus 13 divided by 2. So adding fractions, we must have a common denominator. This is kind of like negative 6 over 1. So if I want to get it to negative 6 over 2, I'm going to have to multiply it by 2. So I end up with negative 12 over 2 plus 13 over 2. Negative 12 plus 13 is a half. So I get 3x is equal to 1/2. Divide both sides by 3. I might just keep going down the page here. So I get x is equal to 1 over 2 divided by 3. Now I don't ever divide fractions. I always multiply by the reciprocal. So I end up with x is equal to 1 over 2 times 1 over 3. Maybe times isn't the best thing to include in there. 1 times 1 is 1, 2 times 3 is 6. So I end up with x is 1 over 6. Now, how many math things did we just do there? We've common denominators for adding our fractions. We've got, we don't multiply fractions, or divide fractions, so we multiply by the reciprocal. This is just like everything you've learned in math in the last 5 years in one question. It can be a bit overwhelming, and it's easy to kind of lose sight as to where you're going, but remember, we're just trying to figure out what x and y are. All we're doing is plotting two lines, and if we can figure out where those lines intersect, that's the answer. So, I have an x, which was 1 over 6 from right here, and I have a y, which was negative 13 over 8 from there. Now, we could substitute those back into our equations and verify our solution was correct, and I encourage you to do that. But in the idea of saving perhaps a little bit of time and doing this last question, I'd like to just maybe move on. You can always substitute those back into the equations and check. If you want to do that, you can. So I know that was a lot to kind of take in. I hope, though, that as you guys go through these questions, you don't lose sight of what we're trying to do. We're trying to figure out where two lines are crossing. That's it. The algebra gets a bit complex. You got a lot of variables, and the process is a bit confusing, perhaps, but the big picture, two lines are crossing. Where do they cross? X and Y coordinate, that's it. So that's what solving a system of equations is. Alex, of course you have an off-topic question. What is it? Let's have it. I'll get ready to do the third example while you think about your off-topic question. So last day we did a couple word problems. We have one now. I might be able to get to another one from last day. Might have a little bit of time left to get to the last one. And then that's it for this whole unit. Really short one. I'm not sure that's entirely off topic. That's point slope form. So y minus 7 equals 5x plus 8. What are the points of the equation? So the points are going to be negative 8 and positive 7. So if you want to think about just changing the sign, so you have the y minus 7, the y point is going to be the opposite sign, so plus 7. And then you have x plus 8, your x point is going to be negative 8. So your point is going to be negative 8, 7. Think about just flipping the signs. I know it's kind of confusing. Remember when you have slope point form, you have y minus, y1 is m, x minus x1. So the minuses that are in this kind of change your sign. Slope is going to be negative 5. Yep, Alex, you're right. Slope is not positive 5, but negative 5 because you have that negative m there. And that's another good point, Abby, as well. Yeah, sometimes we do end up with fractions. And that's why it's important to be confident in your answer. A lot of times these things will work out nicely. They're kind of designed to work out nicely, that they're not going to be like really crazy fractions. But you know, sometimes you get one that has a fractional answer and you just kind of got to roll with it. So don't think just because you have a fraction, what you're doing is incorrect. Sometimes it just works out that way. All right, everyone's favorite word problems. These ones are hard for me to teach to you because there's so many variations of the problems. They can look like so many different things, and I can't prepare you for every situation. Whereas when I say, okay, we just need to add these two equations together, that's kind of straightforward, but you know, the words can change, the equations could look different. So the more you get exposed to, kind of the better off you are. Nuri invested $2,000 at an annual interest rate of 8%, and the rest at a rate of 10%. After 1 year, the total interest was $190. So the idea here is we have two amounts of money. One's invested at 8%, one's invested at 10%. We know how much money we invested in total, but we don't know how much at each percentage, and then we know how much money we made or earned in the year. So let's see if we can come up with a system of equations to kind of model this question. So first thing is we have two different investments, so we're going to need two variables. In this case, x and y makes sense because if we try to pick like an I or something, how do we know which one's the first investment and the second? It doesn't matter what you pick, but x and y is easy. So let's let x equal the amount invested at 8%, and let's let y equal the amount invested at 10%. That's kind of an interesting question, Abby. Just because it's x and y, it doesn't have anything to do with coordinates. No, x and y in this case is just two variables, x, y. You could have picked a, b, whatever. It doesn't matter what they are. But because we're solving a system of equations, really we're trying to find the point. We're going to come up with two equations, essentially two lines. Where those lines intersect is going to be the solution. So even though we've picked x and y, which are just kind of arbitrary variables, it is an x and y sort of system. If we picked a and b, we plot a graph, you're going to have, you know, a and b on the axis. So it kind of is related, but it kind of isn't. I don't know if that answers your question. Okay, so looking back at the question, it says that we've invested $2,000 in total. And we just said, okay, x is how much we invested at 8%. Y is how much we've invested at 10%. So if we added x and y together, we know that the amount we've invested in total is 2,000. So we can come up with our first equation, which is just going to be the amount x invested at 8%, which is x, and the amount invested at 10%, which is y, is equal to 2,000 because we've invested $2,000 in total. So that maybe is the first sort of equation. The second information or second sort of thing we're given in the question is we know that we made $190 in interest in 1 year. So if we can take that and kind of work with it, the interest is 8% of x, which is 0.08 times x. So that's the amount we earned at 8%. So if we took the interest rate of 8%, multiply it by the number of dollars invested at 8%,